Hello, Professor. Good evening. Myself, Gauri Sudha Kandukuri, and I'm here to explain my project for data analysis in construction management. And my project title is Deep Learning Based Object Detection Techniques for Crowd Counting Applications. So let's start with introduction here. I have given a little overview of my project here. So my project overview is about crowd counting and its importance, and a small point like a real world applications like a public safety, transportation planning, and event management. um, Coming to objective, developing a model to improve crowd counting in dense and complex scenarios. I have a problem statement here. So coming to the problem, my project identifies that crowd counting is a big task, especially in dense crowds. For example, overlapping individuals, occlusions, background clutter. So for this, we need more and more accurate and efficient methods to resolve this problem. So I have choose a method to resolve this problem. For that, firstly, here I will be using a COCO ResNet model to identify the head of the people in a given image, and then I will be fine tuning to train our model. Then I experimented with different number of iterations and learning rate to get the best results. So this is my data preparation. Here I have taken 45 scenes in the data set, including 24 scenarios in the training set and 11 scenarios in the test set. Total of 5066 images and 1,32,013 head labels with bounding boxes. We provide information for each visible head here. So here is my methodology. My first step is to develop a crowd counting model using object detection networks, then data preparation, data augmentation. I used COCO ResNet model for this, and then hyperparameter tuning, plotting, and finally to determine the results I have used all of these steps. This is my project workflow. So I have 7 points here to go with. So my first one is importing necessary libraries, and then download pre-trained weights of a Foster RCNN model using the COCO dataset from the Keras application module, and load the dataset using generate training data function, and then building the model by creating a mask RCNN object and modifying the output layers to predict the density maps. Next, implementing mask focal loss using the mask focal loss function, which is used as the loss function for training the model. Then taking number of epochs 500 to get better results and outcomes. Finally, the model is then used to predict the density of the people. With the help of that, I've saved the folder to predict the densities. Here are the results for my project. So finally, my overall accuracy of the project was 0.67, that is 67%. Here are the strengths and limitations of my project. So coming to strengths, accurate head detection is the main part, and high performance in dense scenarios is bit hard, but this method is much better. So coming to limitations, computational cost and dataset diversity are the big task, and future directions for research is large, more diverse datasets exploring GANs and transformer based architects. And conclusion of my project is crowd counting is a challenging computer vision task with various applications in public safety, traffic monitoring, event management, and urban planning. In this project, an object detection based crowd counting model was developed and its performance was evaluated on a large and diverse dataset. The model demonstrates accurate and reliable estimation of the number of people in an image and outperformed other methods in dense crowd scenarios. And the below point is for the link for the code execution. Thank you, Professor.